Great. Welcome everyone for our final episode of CPD in 43 for 2024. It's been a great year. We've had 12, we're about to have 12 talks this year and have scheduled almost 12 talks for next year already. We will be issuing a full year calendar of events for that very soon. Our final talk for December is coming from Moy Materials, Blue Green Roof Technology, and it's from Seamus Farrell, who is over in Ireland, but also has connections with the rest of his company throughout the UK and Europe. So without further ado, I'll hand it straight over to Seamus. Please, if anyone has any questions, please upfield them in the chat box. We will field them at the end of the talk, and look forward to the session.
So thanks very much. Thanks for that intro, and thanks everyone for tuning in today on your lunch break. And thanks very much for the CIAT guys for setting this up. So my name is Seamus Farrell, and I work as part of the business development team in Moy. My background is in architectural technology. I previously worked as a technologist in Moy Materials. And my current role now is the specification lead for mission critical projects in Ireland, supporting clients, architects and main contractors. So this presentation aims to provide specifiers and designers like yourselves guidance and assistance on how to design and plan for a blue-green roof. Firstly, I'll explain the technology available to the roof designer. I'll present a logic chain that can be applied to the design process. I'll then alert you to the challenges that a green roof can present, and I will assist you in avoiding difficulties that may arise. And all in all, I'll explain the processes involved in the development of a blue-green roof waterproofing specification. So the agenda for today, firstly, I'm going to briefly introduce Moy to those who aren't familiar with us. I'll then go through some of the design considerations for when working with blue-green roofs on projects. And then I'll go through in detail the different systems available to the clients and the benefits of installing blue-green roofs. So very briefly, Moy are a privately owned business that specialise in delivering high quality flat roof waterproofing systems that provide critical solutions to infrastructure across Ireland, Europe and the UK. Our core values revolve around integrity, partnerships, social responsibility and continuous evolution, with the purpose to provide our customers with a high quality technical service and a seamless experience from the conception to completion of a project. And these pins highlight the countries where our business has experience in supporting critical infrastructure projects. And these projects kind of consist of some of the most challenging sectors known to the flat roofing industry, such as data centres and pharmaceutical facilities. However, in the UK and Ireland, we'll work on every sector, from small residential developments to large commercial projects. So now I've completed the brief introduction, it's time to move on to kind of the design considerations for when designing a blue-green roof system. So firstly, to start off the presentation, what is a blue-green roof? And I'll begin with some simple definitions. I'll firstly explain the definition of a blue roof, and then I'll explain the definition of a green roof, and these combined create a blue-green roof system. So a blue roof is the roof of a building that is designed to provide temporary water storage and release it over a period of time, usually between 24 and 48 hours. And a green roof building is any structure upon which the final finish will be a vegetative layer of any kind. And to summarise the kind of different layers of a blue-green roof system, which you'll see on screen there, from top to bottom, firstly, the partial or complete covering of vegetation. And this is what's seen once the roof is completely installed. This can be, an extensive seeding blanket. It could be, shrubs. It could be trees, water features. It's essentially, the finished roof, and it's what's seen when the client looks out on the building. Next is the ground medium. So this is essentially, the soil layer. It's a fancy word for the soil layer to allow that vegetation to grow and flourish. Then we have the filtration layer, which essentially blocks sediment from reaching the drainage system, and that's installed directly underneath the living layers of the roof. Then we have the drainage and reservoir board and the attenuation void former. And the purposes of these layers, which is a key component in the blue roof system, is to provide that temporary water attenuation within the roof system. Then we have a protection fleece, and this is a really important layer. It's installed once the waterproofing is completely finished and signed off, and it offers mechanical protection between the green roof system and the waterproofing system. And then we have, the typical flat roof waterproofing membrane, which will usually be an anti-root membrane to resist the damage from roots, and then your insulation and your vapor control layer. So I'm just going to briefly go through some of the key terminology that's involved in blue roof systems. Some of these definitions are kind of more engineering definitions as opposed to something that an architect would be familiar with. So I'll begin with the HMAX, which stands for hydraulic max. And this is essentially the maximum water level to be within that void former. So this is usually determined by the project-specific blue roof calculation, and it'll differ from project to project. Next is a design storm. So this is a specific rainfall event that's defined and described by the statistical likelihood of the event occurring in a given rainfall year. So when we are given a blue roof project brief, we will always look and see what the design storm which measure the specific.
Hi, Seamus.
Sorry,
I
guys, I just
think,
cut out there. Can you guys still hear me?
yeah, hi, Seamus. I
You can hear
think
me.
that it cut out for a little bit. So probably about half a minute back, roughly.
Perfect. So was I on this slide here?
The key terminology you was on.
Yeah.
And I believe when it cut out, you was talking about allowable discharge.
Okay, perfect. I'll just go back to the return period part just in case anyone missed that. Apologies about that, guys. Um so the return period is essentially it's a measure that's used to estimate the likelihood of a specific rainfall event happening within a given time frame. And the most common one is a 1 in 100 year event. So this basically means it's a 1% chance of the storm occurring within a given year. So every project that we look at, there will be a specific return period in which the roof will be designed to contain. And then finally, allowable discharge. So this is a figure that's stated in litres per second, and it states the rate of outflow from the site. And this is usually defined within the SUDS plan. And it's driven by the planning application, and it'll always be provided to us at the beginning of a project when the designer requires a blue roof on the project. So that's just some of the key terminology involved in blue roof systems. So moving on to kind of some of the benefits of blue-green roof systems. So blue roofs are designed to slowly drain stormwater over a period of time, and they reduce the impact of what's called pluvial flooding. And this is a type of flooding that occurs when the public drainage system overflows due to heavy rainfall. They reduce the pollution of waterways in urban areas, which is caused by combined sewer overflows. So in urban areas such as the centre of London or the centre of Dublin, kind of older cities where it has an old drainage system, and the foul and the surface water is actually drained within the same pipe. And when there is an extreme weather event, these pipes tend to overflow at the discharge points, which is, always at, a water body, let's say. So, that pollution can obviously cause damage to wildlife within that waterway. They can also promote biodiversity when combined with green roof finishes. They can store water on roofs, which actually reduces the impact of what's called urban heat island effect, and this can ultimately reduce the cost of cooling. And they can also increase the effectiveness of PV panels on the roof due to this cooling effect on the surface of the roof system. So why are blue-green roofs specified? So the main driver for the specification of these is the planning requirements set out by local councils. And it's mainly where space is an issue for other sustainable urban drainage features. And this includes kind of attenuation ponds, underground attenuation tanks. As we are building in these urban areas, there is usually a lack of space for these large attenuation tanks. So that is where blue roofs can be sometimes the only option to provide this water attenuation. And clients and designers sometimes do specify blue roofs or blue-green roofs for aesthetic purposes when combined with green roofs, or to provide water for rainwater harvesting. So moving on to kind of the different waterproofing systems and finishes which can be used in conjunction with a blue-green roof. Firstly, a modified bitumen system which can be fully bonded from deck to the waterproofing is the most common system specified with a blue-green roof. This is because these are tried and tested systems. They're typically the most robust system for a typical roof area. Single ply membranes, which you'll see in the middle, can also be used. However, we will ensure as the supplier that the most robust membrane is specified due to the addition of the water attenuation layer and that extra level of water that's attenuated on the roof. And finally, hot melt systems or podium deck systems. These are used in areas with extreme traffic, such as a ground floor podium, with fire truck or vehicle access. Any roof which has a higher amount of traffic is where we would typically specify a hot melt system. And then the finishes, so there is a range of finishes available. The most common one is just a typical green roof with a sedum layer. Paving and ballast can also be used in conjunction with the blue roof. These are installed in the same way as a green roof, on top of the void former attenuation layer. And moving on, I'm just going to touch on just kind of the different types of green roofs. So these are kind of the finishes that will be installed above the blue roof system, let's say. So the two main different types are intensive and extensive. So extensive green roofs are typically the most common form. And the reason why they're the most common is because they're low maintenance and they're a lightweight system. They're usually used on roofs with no general access, so roofs that are only accessed for biannual maintenance. They have thin layers of ground medium, so typically between 150 to 150 millimeters in depth. They're really only used for aesthetic and environmental purposes rather than functioning as, let's say, an accessible roof space. And the big point on extensive green roofs are they can withstand harsh environments such as wind, droughts, flooding, and high and low temperatures. Intensive green roofs. So these are roofs that typically have a substrate or a soil layer, and typically over 200 millimeters. And there's a greater scope to design and grow elaborate roof gardens. And this is usually done in conjunction with a landscape architect appointed for the project. They're more suited to kind of roofs with high visibility and more public access. And the opportunities are kind of endless with the different vegetation that this roof can support, such as flower beds, trees, and water features, benches, and gravel paths. So here on screen, you can kind of see the different the varying depths of roof gardens and the different kind of mass that's associated with them. And the most important kind of column on this will be the typical attenuation. So when we're attenuating 100 millimeters of water on the roof, of course, that's going to bring a higher loading to the roof system. Now, blue-green roofs are available on any roof and substrate, whether that be concrete, metal, plywood, and this really depends on the structural calculations. And loadings are fundamentally important due to the additional saturated weight of the blue-green roof system and depending on the design and depth of the ground medium. So it's important that we engage with the engineers early on when a blue roof is being specified to ensure that they take into account the added wet weight of the roof system. So moving on to kind of the considerations for the waterproofing, and it's one of the kind of the most important elements of the design is the selection of the appropriate type of waterproofing. And we always ask designers to kind of consider the manner in which the building is to be constructed and ask if the waterproofing system must withstand hardship while the roof is used as a working platform. And the ability of the chosen system to withstand the rigorous attack of plant roots is really important for blue-green roofs, as the waterproofing system must be root resistant as well as being robust. And with this in mind, the system specification that we'll propose will be discussed in length or at length to enable us to propose the best solution for individual projects. And this is to enable yourself to select kind of a waterproofing system with a proven track record in successful blue-green roofs. So the next element to discuss is the attenuation layer, and this is kind of the key element within a blue-green roof system. So the thickness and type of layer that will be used will always depend on the sustainable urban drainage requirements that is set out by the local planning authority, and also the site master plan designed by the project architect. So the HMAX, or the attenuation level, will be determined by the project-specific blue roof calculation, which must be completed to confirm that the design will actually work in practice. And the type of void former, which you can see on screen there, and this will be determined by the loading requirement for the roof system. For example, a ground floor podium roof will require a void former with a higher compressive strength compared to a roof that it's only used for scheduled maintenance. And as a supplier, it's our responsibility to ensure that the correct void former and thickness, and strength is specified for the roof that is being designed. So moving on to drainage and outlets, we always get asked by architects and designers, how many rainwater outlets should be provided for a given roof area. And as a general rule of thumb, a minimum of 2 outlets are needed to prevent blockage. So, if you only have 1 outlet on the roof, if that outlet does get blocked, that roof will begin to flood. As blue roofs are flow restricted, the outlets allow the slow discharge of rainwater. Usually less outlets are needed on the roof. However, sufficient overflow outlets should be provided in case there is a rain event that kind of exceeds the design storm of that project. And the invert level of these overflows will be set at the HMAX level. And the inclusion of a green roof will usually give the designer kind of a far greater potential area per outlet, as the flow pattern of water through our green roofs is dramatically slower than runoff from a regular hard surface. And in all cases, the relevant European standards should be read in conjunction with the FLL guides, part 4.3 and 6.3.4, as there's not currently, a coherent guide which addresses the issue of drainage from roof gardens. So looking at the kind of the outlets installed on a blue roof more specifically, these blue roof outlets are unlike any other rainwater outlet type, such as, a typical gravity drainage outlet or a siphonic outlet. And the purpose of the blue roof outlets is to restrict discharge to a specified rate in litres per second to allow the roof to drain over 24 hours. And the image on the left is, a typical vertical flow restricted outlet. You'll see the flow restrictor, which is installed into the gravity outlet with an orifice which is sized to the specific diameter required. And typically this orifice diameter is between 15 and 30 millimeters and will differ from project to project. This outlet also includes a built-in overflow pipe, ensuring that if the water level does exceed the designed HMAX, the roof will still drain effectively. You'll see on the right hand side, plug outlets can also be used, along with separate emergency overflow outlets, which are both installed into that gravity drain, which you can see noted on the left. So architects always come to us and say, look, designing internal pipework can sometimes be more tricky, depending on the project. So what you see on screen there is actually a shop drawn for a through the wall parapet outlet with the flow restrictor. And above that flow restricted outlet, there is a telltale overflow outlet, which is installed at the HMAX level. And this ensures, if all the outlets do get blocked at the same time, which is of course really unlikely, and there is a telltale outlet, which means that once the kind of the HMAX level is reached, water will spill off the side of the roof and will notify the client that there is a blockage. And this type of outlet allows designers kind of more flexibility when designing blue-green roof systems. And they're all bespoke made to kind of suit the project-specific calculations. So just finishing off the design considerations, roof penetrations, specifically single point penetrations, and these are usually to facilitate cables and piles and can be kind of more difficult to weather than the larger diameter penetrations. And most often, such single point penetrations are an afterthought in roof design. We commonly see instances where a HVAC or an electrical engineering firm are given permission to route cables and take on the weathering responsibility for themselves. And in most of these cases, the cable or the M&E installers will neither have the expertise or the appropriate materials on hand to ensure that a weather-tight seal with a durability that meets or kind of exceeds our expectations for the warranty period. And it's Murphy's Law waterproofing that states that leaks only occur over managing directors' offices or IT rooms. So it's really important that all the design considerations are discussed with ourselves early on to ensure a watertight roof area. And therefore, we'll always design and use penetration devices, such as pipe collars or umbrella handles that are supplied and warranted as part of the waterproofing system and installed only by an approved waterproofing contractor. So they're kind of the design considerations to take into account when designing for a blue-green roof. In this section, I'll discuss the different types of blue-green roofing systems, the benefits they bring, and some further design considerations. So blue-green roofs with an extensive green roof finish are the most common form of blue-green roofs due to their lightweight nature and low maintenance, while intensive green roof finishes can also be used to provide amenity space for the building residents and also to allow any of you landscape architects to get creative with your design. Biodiverse roofs are essentially, green roofs with vegetation blankets with a more diverse range of planting species specific to the local flora of the area. And they're becoming much more common now due to the biodiversity net gain requirements that are set out by the governments. And a blue-green roof can also be finished with a paving or a ballast, and this can be a more cost-effective solution really for projects where there is only a rainwater attenuation requirement and not a biodiversity requirement. So they can be kind of more cost-effective and a more cost-effective option for the client. So moving on to kind of some of the key points when detailing a blue-green roof system. And there are some extra measures that we do take into account when providing construction details for blue roofs. And this is due to the volume of water that's being stored on the roof for an extended period of time. So as penetrations present the highest risk and are considered kind of the weak points on a roofing system, an exclusion zone is installed around the outlet to ensure that any water ingress around that penetration does not track back to the main field area and cause further problems. And you'll see that on screen there. I'm going to move my mouse just hovering over it. You'll see that the AVCL or the vapor control layer is lapped back to the base sheet, and this means that if there is any water ingress here, that it does not track back through to the field area. And these are installed kind of in a box. If you were to look at that and plan, it would be a box around the outlet and 250 millimeters away from the outlet. Some other things to take into account, the flow restrictor and standpipe, and this is obviously sized in accordance with the project specific calculations, and the thickness of the void former, which is shown here. And this will match the calculated water attenuation level, and the outlet is actually fixed through the insulation into the structure, whether that be concrete or steel, and the membranes are bonded onto that steel flange, as you can see here in the detail. So I'm just going to clarify and summarize kind of the engineering benefits of blue-green roof systems. So firstly, we have an increased lifespan of the waterproofing membranes in the system. They provide rainwater attenuation or flood control. They provide an acoustic barrier which works both ways, so internally and externally. They reduce air conditioning and heating costs due to the evapotranspiration of the planting on the roof, which basically provides kind of a cool layer above the roof system. They provide a replacement of green space. They promote biodiversity, and they support pollinator species such as the bees. And they provide kind of noise pollution reduction due to the extra layers of mass on that roof. They provide a reduction of carbon footprint, and they provide habitat replacement. So I'm just going to summarize some of the maintenance requirements for blue-green roof systems. Now, we do have kind of an extensive document that goes into detail um, on this kind of maintenance requirement. So I'll put up my email at the end if anyone wants to receive this document. I have no problem sending it over. So first of all, keep the roof watered. It's really important that, while an extensive green roof is, a low maintenance roof, and once it's installed, that roof does need to be watered to allow that sedum to flourish on the roof. Next, safe access and trafficking. So during the installation phase of the roof, you remember that protection layer that I mentioned back in the first slide. That's really important that's installed once the waterproofing is signed off. So when the following trades are installing the blue-green roof, that it does not damage the waterproofing. Another one is undesirable plant removal or pest removal. So especially, when there's a heavy storm, I know we had a storm last week in Dublin and in the UK, and, green roof should always be checked after a heavy storm to ensure that there isn't any plants out of place or undesirable things, blowing onto the roof. Ensuring the outlets are clear of blockages. This is specifically important for a blue-green roof because of the reduced size of orifice, and these outlets will block much quicker than a typical rainwater outlet. We would ensure, as the supplier, our field technician team will make sure that the outlets are detailed correctly and that the fleeces are turned up to prevent that blockage. However, it is a requirement for the building owner twice a year just to double check that the outlets aren't blocked. And I already mentioned that, the last point there, to inspect the roof regularly and after storm conditions, and to record all actions are taken. And if anyone has any questions on specific maintenance guidance, as I said, there is a full document outlining this in detail. So I'm just going to close off the presentation now. I think I'm still good for time. So look, when we consider the building life cycle, we are seeking to provide roof systems which will yield the greatest possible lifespan. And this utilises products which will have the lowest possible quantity of embodied carbon and which may be reused or recycled upon the end of service life. And we as a company are continually striving to reduce carbon bottlenecks through the selection of appropriate materials and through progressive management of the logistical chain. In the movement of goods, we are always looking to use the most efficient mode of transport and moving only full loads of materials. And as we discussed in today's presentation, the addition of living roofs or blue-green roofs, they offer valuable UV protection, which considerably extends the service life period of the roof. Also by choosing native species, habitat replacement, and we can give back habitat space to the local environment by providing a soil layer which supports key pollinator species like solitary mining bees, for example, who are essentially the heavy lifters of the bee community. And when we incorporate kind of the blue roof technology within green roofing, we're adding the capacity to temporarily store rainfall upon the roof, which becomes a valuable contribution to the local sustainable urban drainage targets, and is also mandated in some, but most now, local authority areas where urban flooding is a cause for concern. And all these measures will make a considerable contribution to the roof when analysed under the BREEAM or LEED methods of environmental assessment. And we can make economical as well as environmental sense to building owners and operators. So just touching lastly on the LEED requirements, and we've actually had to train one of our own staff in LEED assessment. So we do have a pre-construction manager on board now, who can assist any designers in making sure that the roof system specified meets the required LEED requirements. So just to summarise the end of our presentation, and hopefully everyone here is now in a position to appreciate that the practicality of a blue-green roof doesn't just come down to one piece of the construction jigsaw. Only the collaboration of the design team, a system supplier like ourselves, approved contractors, and the main contractor will ensure that this can be achieved. A specific specification is really important to provide a highly functional roof, and I hope that I've demonstrated how each system will have its own place and uniqueness depending on the range of factors that we showed. The build phase is vitally important as well, and making the right choices around a quality system supplier and the subsequent subcontractor is imperative. Working closely together at this point is the most important part for all of us. Close monitoring to ensure that the specification is delivered or as close as can be, depending on the restrictions, is really important. And finally, to ensure that the roof system performs for its intended lifespan, maintenance programs must be in place, and these will vary depending on the roof system that's installed. So we've come to the end of the presentation. This final slide is simply for your own information. I just want to show where this information is available and ensure that you can access the information with ease. So firstly, as a point of contact, you can use myself. You'll see my email is up on screen there. I form part of the business development team, and I will ensure we've staff based in Ireland as well as the UK and Europe, ensuring that we cover both commercial and technical pre-construction and on-site. We also have a wide range of kind of product information available, certification, case studies, and also standard details available online. Our website is actually currently being redesigned, and I'm hoping that it'll be ready for the start of 2025. So please bear with us for the moment, because the current site definitely isn't perfect. We also have MBS specifications available on the MBS platform, which can be downloaded. However, I would always recommend, for bespoke designs, that the technical team or myself or the technical team are engaged with, and so we can create a bespoke project specification. We now have a team trained up on MBS Chorus. So I know in the UK, MBS Chorus is kind of the go-to specification software. And we can now collaborate with architects on Chorus to save time on your side and also to help the specification process. So everything I've mentioned here, certification, product data, standard details, you can access them via the website, or you can just reach out to myself, and my email is on screen there. So that's it, guys. Thanks very much for listening, and I'll will I stop sharing now, or do you want me to keep that up on screen for the minute?
No, keep it up on screen, please.
Cool. Happy
Thank you
days.
so much. Thank you so much for that. We've got some great questions that have come in already, so I'll work my way through those. Huel asks, how do you provide certification against surface spread of flame? So, for example, B-roof T4 versus maintenance strategy and ensuring adequate irrigation during dry weather to prevent the drying out of the vegetation and increasing risk of external spread of flame.
Okay, so how do you provide certification against surface spread of flame? So yeah, our green roof systems are tested to B-roof T4. In the past, we would have gone away with just having our exposed roof system tested to B-roof T4, but we have, I suppose, had to move with the requirements of fire officers on site. So we do have a cert that confirms that. Versus maintenance strategy and ensuring adequate irrigation during dry weather. So on the irrigation side of things, we would always recommend that there is kind of a source of water, or a water source close to the roof system. So that can be a tap, for obviously smaller developments, that could be, a tap that and a hose that can be used to water the roof. Whereas we see on kind of the commercial developments, the larger commercial developments, perforated pipes, for example, could be laid within the roof system, and a twist of a tap could allow that irrigation to happen. And we typically say, a dry period, between 6 and 8 weeks of no rain. I know in Ireland and the UK, we do get a lot of rain, so it's usually not an issue. But we'd always recommend that there is some form of water source or irrigation on the roof. And I think that was that the last part of that question.
Yeah, I believe
Yeah,
so. But also,
perfect.
you mentioned about the green roof being certified. Is there any difference between the intensive or extensive or types of flora, fauna that's actually been planted, or is it sort of a general rule and to keep it irrigated, etc.?
So for the irrigation, the extensive green roofs, they don't need to be maintained as much as an intensive green roof. We would still recommend a water source, be provided pretty much just if there is, a period of drought. However, the intensive green roofs do require, extensive irrigation. We always say if it's an intensive green roof, think of it as if it's your back garden. This is usually we usually collaborate with the landscape architects on the project because they would usually be involved when there is an intensive green roof. Because we see anything from, shrubs and trees sometimes being planted on the roof. So that's kind of the main point on that. And the B Roof T4 cert that we have does cover all forms of vegetation. So we basically tested it to the government requirements for a green roof system. So I can share that cert, and I put up my email. You can see my email on screen there. And if you just reach out to me, I can send through. We have kind of a short form version of that cert, and that kind of outlines the parameters of that test. If anyone is interested.
Great. Nick asked, what are the typical costs per square meter of a blue/green roof system?
Yeah, so I knew I was going to get this question. So look, we're I think I don't know if I touched on this in the introduction. So we're a supplier of roof materials, and we would appoint one of our approved contractors to install the roof system. Now, our warranty does cover installation and design, because we have a team of field technicians that kind of check each layer of the roof is being installed. So it would be hard for me to give a supply and install all rate. But as a kind of a general rule of thumb, a blue-green roof system would be, substantially higher than a standard roof system. I can do budget costs. If anyone is interested, just reach out to me. I can, get one of our approved installers to give a budget cost of a blue-green roof. But because of the extra layers, of course, it is going to be more expensive, and it varies from region to region as well. So if you just reach out to me, Nick, and just give me a text, let me know what region the project is in, and we can get a budget cost. But it's very hard for me to give a supply only cost, when it'll be different roofing contractors in different regions, obviously, given a supply and install cost. So I hope that
Great.
kind of answers the question, but I knew I was going to get a question on cost.
Thank you. I've got a question from Hernando. Can we have a plant like AHU on top of Blue Roof? And can the void former, does the void former have a compressive strength to receive plant load if plant is supported by a Bigfoot system?
Yeah, so that's a really good question. I did touch on kind of the podium roof decks where we have kind of obviously cherry pickers and fire trucks, and driving over that roof system, and that's where we would specify kind of a higher compressive strength void former. So the void former we have is 40 ton per square meter. Now sometimes plant may be substantially higher than that. But there is always a way around these things. A plinth could be used to support the plant, and it just slightly reduces the area of attenuation. But when we're told about kind of the plant on the roof early on, we usually work around it. It hasn't been too much of a problem to us as of yet. But certain plant can be installed on top of the void former, depending on the compressive strength, or the weight of that plant. But that kind of hones the point, of collaboration with the M&E engineers that are installing the plant to ensure that the roof system can withstand that plant on the roof. So yeah, I hope I answered that question. But we do have a higher compressive strength void former, and that is more suited to the higher loads.
We've got a question from Tim. Do PVs just sit over the CDM, or do they have gravel under the PVs? I think this is something that comes up quite a lot, because I think in a previous talk, there have been instances where PVs have been installed and screwed directly into the membrane. So it might be worth sort of extrapolating on the answer for this a little.
Yeah, so look, that with a green roof or a blue green roof with PV panels, the typical system is a ballasted system. So the PV panels will be laid on the exposed waterproofing membrane, and then the roofing system will be installed in and around that PV panel, and it'll give that kind of 80 kg per meter squared ballast weight to hold down that PV panel. Now we do have a really good construction detail showing this. We wouldn't recommend kind of planting we wouldn't recommend the sedum to continue underneath the PV panel. As you can imagine, it's a shaded area, and the plants would eventually start to look pretty sad underneath that PV panel. So we usually recommend the ballast region. So underneath the PV panels, there'd be a region of ballast, and that would kind of provide the fire protection first of all, and also it would still allow the water to flow underneath that roofing system. So they can be installed on top of the waterproofing or on top of the void former. And as long as we have that 80 kg per meter squared ballast weight, to sufficiently hold down the PV panel, then there's no problem at all. So yeah, we wouldn't be fixing a PV panel through the waterproofing on a ballasted system. So any blue, green, paving system, anywhere where we have that ballast weight, we would always just lay the PV and just ensure that we have that ballast weight to hold down the system. But we do have a construction detail that shows two different options, so I can circulate that. My emails again is on screen there. Just reach out and I can send through them details.
Great, thanks for that, Seamus. And then we've got a final question from Simpson. Do trees have to be raised up in container beds for additional soil depth?
To be fair, it'd be probably a better question for a landscape architect, but I'll try answer it in the best way possible. So, when there's trees being installed on an intensive green roof, because we would never be able to, grow a tree with 50 millimeters of soil. You're looking at upwards of, I want to say 800 millimeters of soil. We have seen raised planter beds being installed on top of blue roofs. So the good thing about the void formers is that concrete can be poured on top of them. Even on just a typical drainage board, a plinth or a planter can be installed on top of the drainage board. And that still allows water to attenuate underneath, and also water to flow maybe from an area of a roof if it needs to get to a rainwater outlet. So there is actually an image. I don't know if it's in the presentation, but I can circulate that as well. It's a really good image that shows kind of a planter bed with the concrete poured on top of the drainage board, and it'll allow the water from one area of the roof to get to that rainwater outlet. So for trees, you would be looking at in the higher thicknesses of soils. But once it's contained within that concrete planter bed, or if the soil is just loose laid on top of the void former, it would still allow water to drain underneath that, because we would have our fleeces that would stop kind of any of that sediment from reaching the rainwater outlet. So I hope that kind of answers that question. But we would always work with the landscape architects once, because of course they're kind of hired hired by the client to go through that kind of diverse planting such as trees, etc. But we'd always work in conjunction with them to make sure that the correct soil is used, the correct thickness, etc. is used.
Um, I do have a question as well. I just wanted to ask
Yeah,
is
no worries.
regarding the blue roof element, um, the the amount of water that's able to be stored, can that be used in regards to your surface water calculations, and also what is typically allowed for that? So how much of a percentage can that be attributed towards? In my experience, it's quite a small percentage. So I just wanted to understand the uh, ultimately the benefits of the blue roof system and how that's been developed over the years.
Yeah, so I suppose the main reason why blue roofs came into the market, we wouldn't be, out trying to sell blue roofs to every single architect and client that we work with. The main reason why we basically had to move with market trends and move with the government requirements, and the reason why they're specified is because, if you have a greenfield site with a new build residential apartment scheme, for example, being built on top, you're essentially reducing that greenfield runoff rate. So the purpose of the blue roof is to, once that's installed, it brings it as close as it can to the original greenfield runoff rate. So in a greenfield site, it'll be typically 2 liters per second per hectare. That water will filter through the ground and back into the water cycle essentially. Once there's concrete and flat roofs and everything being built, that's pretty much going straight back into the waterproofing system. So the blue roof basically adds a buffer on that roofing system to slowly drain that water. So that's really the sole function that of why blue roofs are specified. With a green roof, if we're looking at them kind of separately, a green roof system will typically have a 25 mil drainage board or a 40 mil drainage board, and that will kind of give some level of permanent attenuation on the roof. As well as kind of the soil layer, which will obviously absorb some of the water. So we do see some sites only requiring a green roof, but when there is that kind of 2 liters per second, as an example, outflow rate from that site required by the it's usually a consultant engineer that's appointed early on to basically state that SUDS measures are needed, and that's when we would add in the kind of blue roof attenuation crate, and it basically just reduces strain on the existing drainage system, because on a typical flat roof, it's designed to get the water off as quick as possible. And of course, with climate change and rainwater events increasing over the years, the existing drainage network, in Dublin and London, for example, just cannot withstand that increased rainwater discharge. So the blue roof essentially holds the water on the roof, and then it slowly drains over 24 hours and doesn't it reduces the strain on the drainage system. So there is kind of differences between a blue roof and a green roof, and they're kind of used for different reasons. But you kind of get the best of both worlds when you have a blue and a green roof within the one system, and it is the most typical system we see. There has been a few projects where it's just been a blue roof crate with paving, for example, on top. So permeable paving would allow the water to drain through and attenuate. However, we do see, look, green roofs are the most common finish on top of that void former. So I hope that kind of answers
That's perfect. Thank you
that
so much.
question.
Obviously, if anyone else has any other questions that they'd like to pose to Seamus or any of his colleagues, you have any projects that you'd like to discuss in more detail, then please do reach out to him directly, and he can then port you off to relevant colleagues in various jurisdictions. They do offer quite a lot of different specialist commercial membrane systems, sealing systems, and so on. So it's quite an interesting company with quite a lot of experience in this area. So I advise you to have a look at their website and maybe reach out for any other talks that may be relevant to you. Thank you so much for everyone for attending this year's talks. If you do have any suggestions for future talks, please do let me know. Any feedback is very greatly received. Apologies that there was a slight issue regarding technical um, matters earlier on in the talk, but I think Seamus handled it very seamlessly, to be honest. So thank you for that. And as you mentioned, Murphy's Law, obviously anything that can go wrong will go wrong. So I guess he was just proving that by having some technical difficulties at the same time. But thank you very much. We will be issuing a full schedule of events for next year. Thank you so much, Seamus. Thank you to Moy, and thank you everyone who has attended the talks throughout the year and attended today. And I look forward to seeing you all in the new year. Have a lovely break. And yeah, see you in 2025.
Thanks, everyone.